Good morning to all. Myself C. Kasturi, Assistant Professor in the Department of Mathematics in Erode Sengundar Engineering College. Today we are discussing about the unit, limits and continuity. We know the definition of the limit. That is, the limit is defined as a value that of a function approaches the output for the given input value. So this is the basic definition of a limit, and we know the definition of a continuity. A function is said to be continuous in a given interval if there is no break in the graph of the function in the entire interval range. Those some of the limits applications. So the limits helps to measure the strength of the magnetic field and the electric field and some other etc. So the limits are used to make all the basic definitions of calculus. For example, limits are used to define a continuous function. The conventional definition of a limit implies that every function is continuous at every solitary point of its domain. This is the definition of a limits and continuity in calculus. So now we will move to the topic. The first topic is representation of a function and limit of a function, continuity, derivatives, differentiation rule, and the last topic is maxima and minima of functions of one variable. These are the topics in this limit and continuity. So the first definition is how to represent a function. A function is the relation between two sets of variables such that one variable depends on the other. We can represent different types of functions in different ways. Generally, we are represented using formulas and graphs. So there are four ways for the representation of a function, such as algebraically, numerically, visually and verbally. These are the four ways to represent a given function. So and the next definition is real valued function. A function whose domain and codomain are subsets of the set of all real numbers is known as a real valued function. And the next one is explicit function. If x and y be related that y can be expressed explicitly in terms of x, then y is called an explicit function of x. So the definition is x and y be related, but y can be represented explicitly in terms of x only. That is the definition of an explicit function. For example, we have y equal to x square minus 4x plus 2. So in this example, y can be expressed particularly in terms of the variable x. So this is the example for an explicit function. And the next definition is implicit function. That is, if x and y be related that y cannot be expressed explicitly in terms of x, then y is called an implicit function of x. Have an example, x power 3 plus y power 3 minus 3xy equal to 0. So in this case, y cannot be expressed explicitly in terms of x. That's why this is an example for an implicit function. And the next definition is domain, codomain, range and image. So let me take f. That means f is a function from a to b, and the set A is called a domain of a function and set B is called a codomain. The set of all the images of all elements of A under the function f is called a range of f, and it is denoted by f of A. The range of f is denoted by f of A, which can be written as f of x such that x belongs to A. Clearly, f of A contains in B. This is the definition for a range. And if x belongs to A and y belongs to B and y equal to f of x, then y is called an image of x under the function f. The next definition is graph of a function. If f is a function with a domain D, then the graph is the set of all ordered pairs. that is x comma f of x. In this case, f of x is the value of y. So generally we can take x comma y. X belongs to the domain D. So this is the definition for graph of a function. So these are the basic definition in this unit. So we will move to the problem. The first problem, we have to find the domain and the range and then sketch the graph of the function. The first problem is f of x equal to x square. Now we will move to the solution. So we can take f of x equal to x square. Let me take f of x equal to y. So we can take y equal to x square. We know y equal to x square is a parabola open upwards. So we can draw a graph that is a parabola open upwards. So we want the ordered pairs. That means we want x and y values. So we form a tables. So in this case, the domain is taken as x and the range is taken as y. So we know y. What is y value? Here they are given y equal to x square. So x is the input value and y is the output value. So we can take all the real numbers 0, 1, minus 1, 2, minus 2, 3, minus 3 up to etc. So what is the output? The output is a range value. So we can substitute y equal to x. Then we get x equal to 0. Then we get y equal to 0. Suppose we put x equal to 1, we get y equal to 1. And x equal to minus 1, we get y equal to plus 1. And x equal to 2, we get y equal to 4. And we put x equal to minus 2 and y value as 4. Similarly, we can substitute the remaining values. So generally, the value starts from 0, 1, 4 up to etc. This is the value for y. So our input is all the real numbers 0, 1, minus 1, 2, minus 2 up to etc. That means from minus infinity to plus infinity. That is our domain. So now we will plot the graph by using the points x and y. So what is the x and y points? 0, 0, 1, 1, minus 1, 1, 2, 4, minus 2, 4. So we can point all the points in our graph and we can join all the points. We get a parabola open upwards. So this is the graph of the given function. So we will conclude the given problem. Therefore the domain is nothing but x value. So what are the x values? Between minus infinity to plus infinity. Therefore the domain is minus infinity comma plus infinity. What is the range? That means the output value. What is the output value? Starts from 0, 1, 4 up to etc. It goes on positive sides. Therefore the output is 0 comma infinity. That is the range value. And this is the graph. Is it clear? So we will find what is x and y. And by using this x and y, we can draw a graph. So we can write the conclusion. Domain, range. Domain is nothing but x value. Range is nothing but y value. And we can plot a graph. This is the first problem. The second problem, find the domain and range only. We do not draw a graph. So domain is x value. Range is a y value. That is the concept. So what is the given problem? F of x equal to 1 plus x square. So we know f of x equal to y. So we can write y equal to 1 plus x square. So we can write y minus 1 equal to x square. So we know x square is strictly greater than or equal to 0. That is a known condition. So using here we get y minus 1 greater than or equal to 0. We get y greater than or equal to 1. Therefore y value starts from 1, 2 up to etc. That is the range value. What is our input? Domain value minus infinity comma plus infinity. This is the one of the way. The another way is as usual. We can find what is x and y value by using the table. So what is x value? So we can take all the real numbers between minus infinity comma plus infinity. So here we can take 0, 1, minus 1, 2, minus 2 up to etc. So our output is 1, 2, 2, 5, 5. These are the output value. So anyway, we can use this method or we can use the table method. So which is your convenient, you can use. So anyway, we get the same conclusion, that is domain is minus infinity comma plus infinity and the range is y value. So here y, in this table y starts from 1 to 5 up to etc. Therefore we conclude 1 comma infinity. So this is the solution of domain and range. The next problem, they are given f of x equal to root of 5x plus 10. So we know f of x equal to y. Here also we have two methods. So one method is you can simplify the given equation, another method is a table format. So we know the square root of a function is strictly greater than or equal to 0. What is our square root of a function? 5x plus 10. So 5x plus 10 greater than or equal to 0. In this case, we get x greater than or equal to minus 2. So here the input value of x starts from minus 2. So we will see the table. So we can take minus 2, minus 1, 0. It's move on positive sides. We can take some values only. Yes, we are taking minus 2, minus 1, then 0, 1 up to etc. We can substitute some values in the right hand sides. So what are the output value? Now this is our given equation, y equal to root of 5x plus 10. So we can substitute x equal to minus 2, we get y equal to 0. X equal to minus 1, we get y equal to 2.24. And x equal to 0, we get y equal to 3.16. And x equal to 1, our y value is 3.87 up to etc. So generally y starts from 0 to infinity base. So this is the domain value. Therefore we conclude that the domain is nothing but a x value. Starts from minus 2, minus 1, 0, 1 up to etc. up to infinity. Therefore minus 2 comma infinity is a domain. What is the range here? So range value is nothing but y value. So y starts from 0 and it's moved towards the positive side. Therefore the range is 0 comma infinity. Is it clear? So this is the domain and range value. So third problem, f of x equal to 4 by 3 minus x. So here also we can take f of x equal to y, that is equal to 4 by 3 minus x. So we know the rule, division by 0 is not allowed there. Therefore, what is the division term? 3 minus x. So we get x equal to, can comparing with 0, we get x equal to 3. Therefore, here we can take the domain as, here 3 is not included because suppose we are substituting 3, the denominator getting 0. This is not allowed. So we do not put the value 3. Therefore, generally we write the domain as minus infinity to plus infinity, but here 3 is not included. Therefore, minus infinity comma plus infinity can be split into two parts. That is minus infinity comma 3 union 3 comma infinity. In these two intervals, 3 is not included in these intervals. Therefore, we know the range value. Range is nothing but, suppose we are putting 0 means 3 means, what is the y value? 0. Therefore, the range is minus infinity